Hello students, this is the part 2 of the problematic section in the linear independency and linear dependency. So we are checking for a test for linear dependency and the vectors are given here. So let us dive directly into the solution. We know the general form, that is a1x1 plus a2x2 plus a3x3 is equal to 0. I made a mistake there, please correct it. It is a2x2. All right, so it is a1 into the first vector, a2 into the second vector, minus 2 1, plus a3 into the third vector, 1 minus 6 5. All right, is equal to 0. Then what we have to do is we know that in the equation we need three terms, right? a1, a2 and a3. So what we will do is we will multiply the first terms of the all the equations. All right, so it is so first equation we will form, we need three, we will get three equations since there are three vectors. So a1 plus 3a2 plus 3a3 is equal to 0. Then the second term, right, 2a1 minus 2a2 minus 6a3 is equal to 0. Then the third equation, that is 3a1 plus a2 plus 5a3 is equal to 0. It is very clear these equations are not in the reduced row echelon form, so we will do that. So I will write directly the augmented matrix. So it is 1 3 1, 2 minus 2 minus 6, 3 1 5, given 0 0 0. Now what we have to do is we will apply the row reduction, that is row 2 changes to, so I will change 2 and the second row and third row. Row 2 changes to row 2 minus 2 times row 1, and row 3 changes to row 3 minus 3 times row 1. Now first row remains as it is, so 1 3 1, then 0, then second row 0 minus 8 minus 8 0. I have the solution, I'm writing it directly. Please pause the video and solve it. All right, now I will try to change this minus 8 to 0. So row 3 changes to row 3 minus row 2. So what we will get, 1 3 1 0, then 0 minus 8 minus 8 0, then 0 0 10 0. All right, so I hope I will stop it here and I will write the equations now. So it is a1 plus 3 times a2 plus a3 is equal to 0. Then minus 8 a3 a2 minus 8 a3 is equal to 0. 10 times a3 is equal to 0. Therefore a3 is equal to 0, right? Now we'll apply a3 to the second equation. So minus 8 a2 minus 0 is equal to 0. Therefore a2 is equal to 0. All right, now we'll apply to the first equation, that is a1 plus 0 is equal to 0, that is a1 is equal to 0. Therefore it is linearly independent because a1 is equal to a2 is equal to a3 is equal to 0. So let's move to the second question. Second question from the VTU question paper. All right, so this is a question and they're asking for they have asked this question for almost like 10 marks. They have included with the definition. So the definition was about vector spaces and vector subspaces, I guess. So please study the definitions along with this. You can easily score marks. All right, we'll solve the first we'll solve the problem. We have to check whether it's linearly dependent. Okay, we have to check for linear dependent, guys. The question was for linear dependent in V3 of R. All right, okay. Now we will write the general form, that is A1. So we'll write general form A1 S1 I'll write because the set is S. So A1 S1 plus A2 S2 plus A3 S3 is equal to 0. All right, so then we will write A1 into 1 0 1 plus a2 into 1 1 0 plus a3 into minus 1 0 minus 1 is equal to 0. Now we will as it is we will write the equations. We need not change it in the reduced echelon form because already it is in the reduced form, right? It is a1 plus a2 minus a3 is equal to 0. Then second term is 0 1 and 0, so a2 is equal to 0. then 1 0 minus 1, so a1, so it is a1 minus a3 is equal to 0. All right, a2 is 0, then we will try to apply to the first term. So let me name the equations. So I will apply substitute 2 in 1. So 2 in 1, I'll write 2 in 1 because it is easy for me to write. It is nothing but substitution. So it is a1 minus a3 is equal to 0. Let me name the equation as 4. So clearly in the third and the fourth equation already there are two unknowns. So if there are two unknowns, it is very clear in mathematics that we cannot solve for it, right? So only if we can solve only if a1 was equal to a3, but it is not the condition here. If that is the case, then I would have got the answer as 0, but this is not the condition here. Then I can, if I take a3 is equal to some value t, then if I try to substitute, then I'll get a1 a1 minus t is equal to 0, then a1 is equal to t, right? So that is a1 is equal to t, then I can write a1 is equal to t, a2 is equal to 0, a3 is equal to t. So clearly I can say that it is a non-zero number and it is linearly dependent since we have some term t. All right, hope you understood this. We'll follow up in the next